The Origin and Fate of the Universe, according to Michio Kaku. Section 1. A Universe Awakens. In the vast stillness of the cosmos, where galaxies drift like glowing lanterns through an endless sea, the question has lingered for as long as we've looked up at the night sky. Where did it all come from? And where is it going? Dr. Michio Kaku, a theoretical physicist and co-founder of string field theory, has spent his life exploring the frontiers of science in search of these answers. His voice is not one of certainty, but of wonder, of a scientist who believes the universe is not only comprehensible, but elegant, harmonious, and perhaps even destined. As we close our eyes and journey together into the heart of Kaku's beliefs, we leave behind the familiar world. What awaits is a tapestry woven from the threads of time, space, and possibility. The beginning, not a bang, but a breath. To understand Michio Kaku's view of the universe, we must begin where all things begin, with the birth of the cosmos itself. Most scientists agree that the universe began around 13.8 billion years ago in what we call the Big Bang. But Michio Kaku doesn't see it as just an explosion from nothing. He sees it as a cosmic unfolding, a breath of creation that emerged not from emptiness, but perhaps from a higher dimensional space. In Kaku's mind, the universe may be just one bubble in a much greater multiverse, a sea of universes, each with its own laws of physics, like waves arising and falling in an eternal ocean. Our universe, then, could have budded off from this grander reality, born not as a singular miracle, but as part of a majestic pattern. This idea comes not from dreams or fantasy, but from the mathematical structures of string theory, which suggest that the universe may exist in as many as 11 dimensions. In such a landscape, what we call the Big Bang could simply be the collision or separation of higher dimensional objects, brains, setting off a ripple that became everything we know. From simplicity, complexity grows. In the early moments of this newborn universe, there was no light, no stars, no atoms, only raw energy and potential. Kaku describes this period as unimaginably small and hot, where the fundamental forces of nature, gravity, electromagnetism, and the nuclear forces were unified, indistinguishable. As the universe cooled and expanded, these forces began to separate, like instruments tuning themselves before a great cosmic symphony. Matter formed, stars ignited, galaxies spiraled outward. From silence came structure. Michio Kaku often compares this unfolding to a symphony, one played out not in sound, but in vibrations of strings too small for the eye to see. According to string theory, every particle, every atom, every cell in our bodies is made from tiny vibrating strings. Their tones, their frequencies, give rise to the illusion of substance. To Kaku, the universe is music made visible. Where are we going? As we float through time, carried gently on this cosmic melody, Kaku invites us to consider the universe not just as it is, but as it will become. Will it expand forever? Collapse into itself? Fade into cold darkness? These questions remain open, but theories suggest three great fates: the Big Freeze, the Big Crunch, and the Big Rip. Kaku leans toward the Big Freeze, a future where the universe continues to expand endlessly, growing colder and darker as galaxies drift apart and stars fade away. It is not a dramatic end, but a slow dimming, like the last embers of a distant fire. Yet even in this quiet ending, he sees beauty, a universe that lived, breathed, and gave birth to consciousness like ours. A universe that may, in time, give rise to new beginnings. As we rest in this moment, weightless in thought, calm in spirit, we are reminded of the vastness of what lies beyond our tiny world. The stars overhead are more than lights. They are echoes of a birth we're only just beginning to understand. And this is only the beginning of our journey. Section 2. The breath of multiverses. In the gentle silence between heartbeats, in the spaces where thoughts dissolve into dreams, the universe continues its vast, silent evolution. According to Dr. Michio Kaku, what we see in the night sky is not the whole story, but a single page in a much greater cosmic book, one written across multiple universes, each with its own tale to tell. The multiverse, a sea of possibilities. Kaku is one of the strongest advocates for the multiverse hypothesis, the idea that our universe is not alone, but part of a vast ensemble, perhaps even an infinite collection of parallel worlds. Some are similar to ours, others completely alien. In his calm, thoughtful tone, Kaku describes the multiverse not as science fiction, but as a natural consequence of modern physics, especially string theory and inflationary cosmology. These frameworks don't just allow for other universes, they almost require them. He imagines space as a kind of cosmic foam, with bubbles forming, growing, and occasionally splitting off to become independent universes. Our own universe may have come from just such a bubble, a small ripple in the deep ocean of possibility. And in this vision, the Big Bang wasn't the beginning of everything. It was simply the birth of our bubble, our chapter, our song, a symphony of laws. Each universe in the multiverse may have its own laws of physics, different values for gravity, different types of particles, different ways time flows. Some universes might collapse instantly, others might never form stars or atoms. But among this diversity, a few, like ours, are finely tuned for life. To Michio Kaku, this fine-tuning is not proof of design, but rather evidence of abundance. If there are infinite universes, it's not surprising that one would have the precise conditions necessary for galaxies, chemistry, and consciousness. He compares this idea to a casino filled with dice being thrown constantly. Most combinations are meaningless, but now and then, one set of dice lands just right, and that's the universe we find ourselves in. It's not luck, it's probability playing out across the fabric of reality. Dimensions beyond sight. How do these universes emerge? What lies beneath the surface of space-time? String theory, Kaku's main field of research, proposes that the fundamental building blocks of reality are not particles, but tiny, vibrating strings. These strings exist not in our familiar 3 dimensions, but in 10 or 11 dimensions, depending on the model. Most of these dimensions are curled up so tightly that we don't perceive them, but they may be responsible for everything we see, everything we are. To visualize this, Kaku invites us to imagine an ant walking on a tightrope. From a distance, the rope appears as a simple line, one dimension. But up close, we see that the ant can move forward and also around the rope's surface, revealing a second, hidden dimension. In the same way, the universe may hold hidden dimensions, accessible not to the eye, but to the mathematics of string theory. And in those dimensions, new universes may be born. The role of consciousness. Michio Kaku is also fascinated by the idea that consciousness is not an anomaly, but a product of the universe's deep structure. He often suggests that intelligent life like ours may eventually shape the fate of the cosmos itself. He classifies civilizations by their energy mastery, from type 1, planetary, to type 2, stellar, to type 3, galactic. We are a fragile type 0, but with time, intelligence and peace, we may rise. And in doing so, we may one day unlock the power to travel between stars, harness the energy of black holes, and perhaps even shape universes, seeding new worlds as ancient ones fade. As you lie still, your breath sinking with the quiet rhythm of the night, consider this: you are not a passive observer of the universe. You are its child, born from stars, shaped by gravity, awakened by time. And in you lives the capacity to wonder, to reach, to dream. The story continues. The symphony plays on. Section 3. The Arrow of Time. Time. It moves in one direction. Forward. Always forward. But why? As you rest in this gentle moment, the present, you are flowing down a river whose source lies in the distant past, and whose destination remains hidden in shadow. According to Michio Kaku, understanding time is essential to understanding the origin and the fate of the universe, and it begins with the second law of thermodynamics. Entropy. Time's silent guide. In the early moments after the Big Bang, the universe was hot, dense, and highly ordered. There was little variety, no galaxies, no planets, no stars. Over billions of years, it has expanded and cooled and become more disordered. This disorder, called entropy, is what gives time its direction. To Michio Kaku, entropy is not just a scientific principle. It is the arrow of time. It explains why we remember the past but not the future, why coffee cools but never spontaneously heats up, why stars burn out but never reignite. In his view, the expansion of the universe and the increase of entropy are deeply connected. As the cosmos grows, complexity rises and time moves forward, carrying everything with it, reversing the clock. But what if time could run backward? In the mathematics of physics, time is often symmetrical. The equations work just as well in reverse, and yet we experience only one direction. This mystery has puzzled physicists for generations. Kaku explores the possibility that in certain extreme environments, such as inside a black hole or near the origin of the universe, time may behave differently. It may stretch, bend, even reverse. In fact, he suggests that at the moment of the Big Bang, time itself may have emerged, along with space. There was no before in the traditional sense, because time did not exist until the universe began to expand. Just as sound needs air and waves need water, time may need space to flow. The cosmic clock. To describe the age of the universe, scientists often compare it to a clock. At midnight, the universe was born. At 1 o'clock, the first atoms formed. At 4 o'clock, the first stars ignited. At 9 o'clock, our galaxy took shape. At 11:59 and 59 seconds, humans arrived. In Michio Kaku's poetic reflections, this clock reminds us not just of how far we've come, but how brief our moment truly is. And yet, within that brief flicker of time, we've asked questions no other species has asked. We've looked back toward the beginning and forward toward the end. This self-awareness, he believes, is the first sign that the universe is beginning to understand itself. The end of time. If time began with the Big Bang, might it also end? Kaku examines several possibilities. In the Big Freeze scenario, time may stretch indefinitely, slowing down in a cold, empty universe where motion ceases and entropy reaches its peak. In this distant future, trillions of years from now, time would become meaningless as nothing changes. In other models, time may loop or restart. Some physicists imagine a cyclic universe, a sequence of bangs and crunches eternally repeating. If so, we may be living in one of many time cycles, unaware of what came before. Kaku does not claim to know for certain, but he holds to one idea firmly. Time is not absolute. It is part of the fabric of reality, and like space, it can bend, warp, or vanish. To sleep beneath the stars, then, is to float not just through space, but through time itself. Tonight, as you drift gently into sleep, know that you are carried by forces older than stars, by a clock set in motion before memory, before life. Time may pass, but wonder, that remains. Section 4. The Dark Energy Symphony. In the silent expanse beyond our galaxy, an invisible force works quietly but relentlessly. Dr. Michio Kaku calls it dark energy, the mysterious engine driving the accelerated expansion of the universe. Tonight, we listen to its silent symphony. A gentle push. For most of cosmic history, gravity held sway. Galaxies clustered, stars formed. The universe slowed its stretch just enough to let structure arise. But about 5 billion years ago, something shifted. Galaxies began receding faster, as if space itself were being pulled apart. Kaku describes dark energy as a cosmic pressure, a gentle but unceasing push. It fills the void between galaxies, making empty space teem with potential. Though we cannot see it or touch it, dark energy constitutes nearly 70% of the total energy of the cosmos. Imagine an enormous balloon. As you blow air into it, its surface stretches. Dark energy is like the breath inside the balloon, inflating the universe more rapidly with each passing moment. The equation of destiny. To understand this force, physicists turn to Einstein's famous equation. E equals mc squared, and his cosmological constant, denoted by the Greek letter lambda, lambda. For decades, Einstein himself set lambda aside, calling it his biggest blunder. Yet modern observations show that this constant may precisely describe the repulsive effect of dark energy. Kaku often points out the poetic irony. The very term Einstein discarded may hold the key to the universe's fate. In the math of general relativity, lambda acts as a smooth pressure, uniform in every direction, stretching space like cosmic taffy. Endless expansion or sudden rupture. If dark energy remains constant, the universe will continue to expand at an ever-increasing rate. Galaxies will drift beyond our horizon, stars will burn out, and space will grow cold and lonely, a scenario known as the Big Freeze. But Kaku also entertains a darker possibility, the Big Rip. If dark energy grows stronger over time, its repulsive force could eventually overwhelm all other forces. First, galactic clusters would separate, then galaxies themselves would be torn apart. Stars, planets, even atoms would disintegrate, until space itself rips in a final crescendo. Even this dire future holds a somber beauty, an ultimate release, a final liberation from gravity's bonds. Harmony in the unknown. Despite its name, dark energy may not be sinister. Michio Kaku reminds us that science has always thrived on mysteries. The quiet pull of dark energy invites us to explore deeper, to listen more closely to the universe's hidden harmonies. He likens the cosmos to a grand symphony. Visible matter supplies the strings and brass. Dark matter provides the percussion. And dark energy conducts the entire ensemble. Together, they weave a masterpiece beyond any earthly concert. As you breathe slowly, sinking into the softness of your pillow, feel yourself immersed in this cosmic orchestra. Let the dark energy symphony guide you, expanding, dissolving, and carrying you at last into dreamless sleep. Section 5. Black holes and the boundaries of reality. There are places in the universe where the laws of physics seem to break down, where light itself is imprisoned, and time ceases to behave as we know it. These are black holes, and to Michio Kaku, they are not just cosmic oddities. They are gateways to the deepest truths of space, time, and the fate of the universe. As you lie in stillness, feeling the gentle pull of gravity holding you to your bed, imagine a force so strong that even gravity, our ever-faithful anchor, becomes a roaring storm, collapsing stars into singularities of unimaginable density. These are not monsters, but rather messengers, reminding us that our universe is stranger and more wondrous than our senses alone can grasp. The life and death of stars. To understand black holes, we begin with the life of a star. Stars are born in clouds of gas and dust, igniting under the pressure of gravity. For millions, even billions of years, they shine by fusing hydrogen into helium, releasing light and heat into the cold vacuum of space. But nothing lasts forever. When a massive star exhausts its fuel, it can no longer resist the pull of its own mass. Michio Kaku explains how, in its final moments, the star collapses inward. If its mass is sufficient, this collapse continues without end. The core shrinks, the density rises, and the escape velocity, the speed needed to break free, exceeds the speed of light. Thus a black hole is born. It is not a hole in the traditional sense. It is a region of space where gravity is so intense that not even light can escape. The boundary around it is called the event horizon, the point of no return. Once something crosses this line, it is lost to the outside universe, falling into the abyss. What would it feel like to fall into a black hole? Kaku often describes this as a thought experiment that tests the limits of general relativity and quantum mechanics. If you watch someone fall in from a safe distance, you'd see them slow down, redshift, and fade away, never quite crossing the event horizon. But for the falling person, time would appear to pass normally. They would fall faster and faster, pulled irresistibly toward the singularity at the center, where density becomes infinite and the known laws of physics break down. This dual perspective, where both realities are valid yet mutually exclusive, hints at a deeper truth, that space and time are not fixed, but relative, shaped by gravity itself. And in the heart of a black hole, space folds inward and time stretches into eternity. Information and paradox. One of the most fascinating debates in modern physics concerns the fate of information inside a black hole. According to quantum mechanics, information can never be truly destroyed. But classical black hole theory suggests that anything falling into a black hole is lost forever, including the data that described its original state. This contradiction has puzzled scientists for decades. Michio Kaku presents the information paradox as a central challenge of 21st century physics. Can both general relativity and quantum theory be correct? Or must one yield to the other in the extreme environments of black holes? Stephen Hawking once proposed that black holes might slowly evaporate through Hawking radiation, releasing energy back into the universe over trillions of years. But if the information is never recovered, does that mean quantum mechanics is incomplete? Kaku believes the answer may lie in string theory, where particles are not points but tiny vibrating strings, and where the fabric of space-time is fundamentally quantum in nature. In some versions of the theory, black holes do not destroy information, but rather store it in subtle surface vibrations, like a hologram, encoding three-dimensional data on a two-dimensional surface. Wormholes and cosmic gateways. Among the most tantalizing implications of black hole physics is the possibility of wormholes, bridges between distant regions of space and time. Kaku speculates that, under the right conditions, a black hole might serve not just as a dead end, but as a tunnel to somewhere or someone else. This is more than science fiction. Mathematical solutions to Einstein's field equations allow for such passages, provided exotic matter with negative energy density can stabilize the throat. Could advanced civilizations billions of years more evolved than ours have learned to traverse these cosmic shortcuts? Could wormholes be how one day we move between stars or even universes? For now, we do not know, but the equations say it is not impossible. Echoes of the infinite black holes are the universe's deepest wells, and yet, from their depths, we learn the most. They teach us that time is not a river, but a fabric, that gravity is not a force, but a curvature, that the universe, for all its silence, speaks in riddles waiting to be solved. Section 6. The Multiverse. Beyond the edges of our reality, as you breathe slowly, wrapped in warmth and silence, your mind begins to loosen its grip on the ordinary. The stars above no longer seem so far. The sky no longer seems like a ceiling. Instead, it becomes a curtain, thin, delicate, behind which lies a vastness we are only beginning to glimpse. Michio Kaku invites us to pull that curtain aside and gaze into what may be the most profound idea of all, the multiverse. What is the multiverse? The universe we know began, we believe, with a singular event, the Big Bang. From that moment, space has expanded, cooled, and evolved into the cosmos we see around us. But what if that Big Bang was not unique? What if our universe is just one bubble in a much larger cosmic ocean? This is the central idea of the multiverse. To Michio Kaku and many theoretical physicists, the multiverse is not merely a speculative fantasy. It is a natural consequence of some of our most powerful theories: string theory, cosmic inflation, and quantum mechanics. Each suggests, in its own way, that the universe we inhabit may be only one of many. Some versions of the multiverse propose parallel universes, invisible but coexisting alongside ours. Others imagine an endless foam of baby universes, each birthed by its own Big Bang, floating like soap bubbles in an ever-expanding hyperspace. And some theories go even further, suggesting that every quantum decision splits the universe into branching realities, each as real as our own, differing only by the outcome of a single event: cosmic inflation and eternal rebirth. Let's return to the beginning. In the earliest moments after the Big Bang, the universe underwent an incredible expansion, called cosmic inflation. It grew from subatomic size to cosmic scale in a fraction of a second. This inflation may not have been a one-time event. Kaku explains how in some models, inflation is eternal. Pockets of space may stop inflating and form universes like ours, while the rest continues expanding. These pockets could be completely separate, with different laws of physics, different particles, even different dimensions. In one universe, stars may be made of antimatter. In another, gravity could be stronger. In yet another, life as we know it may be impossible. The multiverse becomes a cosmic lottery, where every possible combination of laws plays out somewhere. And here, in one of the rare places where the conditions were just right, life emerged. We emerged. String theory and higher dimensions. Michio Kaku is one of the founding fathers of string field theory, a branch of theoretical physics that attempts to unify all the forces of nature into a single framework. At the heart of this theory is a radical idea that the universe is made not of point particles, but of tiny vibrating strings. And these strings vibrate in 10 or 11 dimensions, far beyond the familiar 3 of space and 1 of time. Most of these dimensions are compact and hidden, curled up at the smaller scales, but they may hold the key to the multiverse. Different ways of compacting these dimensions could create different physical laws, producing a landscape of possible universes, each with its own unique signature. In this picture, our universe is like a note played on a cosmic instrument. The multiverse is the full symphony. Dreams and doubts. Of course, not all physicists agree. The multiverse raises difficult questions. If these other universes cannot be observed, are they truly scientific? Can we test their existence? Or are we venturing into metaphysics? Kaku responds by pointing out that many ideas once dismissed as unobservable, atoms, black holes, even the Big Bang itself, were later confirmed through indirect evidence. He believes that as our instruments improve and our theories mature, we may find signs of the multiverse in the cosmic microwave background, in patterns of gravitational waves, or even in the strange fine-tuning of the constants of nature. Why is the universe so precisely tuned for life? Why do the laws of physics seem to fall into a narrow range that allows stars, planets, and consciousness? Perhaps because there are countless universes, and we live in one where life was possible. The infinite mirror. As you drift deeper into relaxation, consider this. There may be a universe where you made a different choice today, another where the Earth never formed, another still where stars never ignited, and somewhere, maybe, a version of you is listening to this same story under a different sky. Kaku sees this not as a reason for fear, but as a source of wonder. The multiverse, if it exists, means reality is vaster and more generous than we ever imagined. It means that possibility is infinite, and that mystery is woven into the very fabric of space-time. Michio Kaku sees black holes as portals, not just to other parts of space, but to a greater understanding of the universe itself. They may hold the secret to quantum gravity, to the birth of universes, even to the fate of our own. As you rest, drifting slowly into deeper calm, imagine a place so dark that it becomes pure potential, a space where endings are beginnings, where silence roars with meaning, and where time and matter dissolve into unity. The edge of a black hole is not the end of the story. It may be the beginning of a new one. Section 7. The Cosmic Mind, Consciousness and the Universe. In the quiet stillness of night, when the noise of the world fades, a deeper question begins to rise within us. What role do we play in this vast, ancient cosmos? Are we merely observers, drifting among stars? Or is our consciousness more deeply entangled with the fabric of reality? Michio Kaku invites us to explore this final mystery, not of matter, but of mind. From stardust to self-awareness, the atoms in your body were forged in the hearts of stars. Hydrogen became helium, helium became carbon, and eventually iron. Supernovae scattered these elements across the galaxy, where they became part of planets and life. But somehow, in the swirling dust and electric storms of early Earth, matter began to think. It began to dream. To Kaku, this transformation, from inanimate atoms to self-aware beings, is the greatest miracle of all. It is not magic, but an emergent property of complexity, energy, and time. Our brains, with their billions of neurons and trillions of connections, are among the most complex structures known in the universe. And yet, they are composed of the same materials as stars and soil. The conscious universe. Throughout history, consciousness has been a frontier science could not easily penetrate. It has no shape, no weight, no color. And yet, it defines all our experience. Kaku approaches consciousness through the lens of physics and information theory. He defines it as a process of modeling the future, of simulating possible outcomes, and making decisions based on memory, perception, and awareness of self. In this sense, even simple organisms possess a basic form of consciousness. But as brains evolve, this consciousness becomes richer, able to imagine, to plan, and to ask cosmic questions. What makes the human mind remarkable, Kaku argues, is its capacity to ask where it came from, to gaze at the stars and wonder what lies beyond them, to explore reality itself, not just physically, but intellectually and spiritually. Are we the universe becoming aware of itself? Carl Sagan once said, "We are a way for the cosmos to know itself." Michio Kaku builds upon this, suggesting that the emergence of intelligence may be a fundamental part of the universe's evolution. In a multiverse filled with chaotic variation, it may be rare for life to arise. But once it does, it becomes a force of curiosity, exploration, and transformation. It builds telescopes, space stations, and artificial minds. It looks back across billions of years and forward across billions more. In this view, consciousness is not an accident, but a phase transition in complexity. A new kind of energy, not physical, but informational. And perhaps, in the distant future, conscious beings will shape the fate of the cosmos itself. Toward the omega point, Kaku speculates that civilizations far more advanced than ours may one day control not just energy and matter, but the structure of space-time. They may be able to escape the death of stars, redirect the course of galaxies, or even escape the end of the universe. This leads to the idea of the omega point, a final state of supreme intelligence at the end of time, where consciousness saturates the cosmos and reality itself becomes a mental construct. It is a speculative vision, yes, but it is grounded in the belief that intelligence is not separate from nature. It is part of the same unfolding process that created planets and stars, a universe that remembers. Perhaps the universe is not cold and meaningless. Perhaps through beings like us, it remembers its history. It sees itself. It reflects. Michio Kaku sees a future where science and spirit are no longer in opposition, but in dialogue, where the questions of philosophy are informed by physics, where wonder is not dismissed, but deepened. And as we lie in the dark, listening to the hum of the galaxies in our imagination, we become part of that story. Tonight, as sleep begins to gather gently in the corners of your awareness, let yourself imagine an endless sky, one that holds not just stars, but entire realities, flickering quietly like lanterns on an infinite sea. You are part of this mystery. You are made of the same elements as the stars, and perhaps you are one thought among many, in a multiverse dreaming itself awake. Section 8. Time, the river of the cosmos. Time, so subtle, so relentless. As you close your eyes and let your thoughts slow, you feel its current, soft but unwavering, guiding you from one moment to the next. But what is time, truly? A ticking clock? A rhythm of nature? A feature of the mind? To Michio Kaku, time is one of the greatest enigmas in all of physics. It is the silent frame in which the universe unfolds, and perhaps the key to understanding its deepest truths. Einstein's time. The first revolution came with Albert Einstein, who shattered the old notion of time as absolute. In his theory of special relativity, time is not universal. It bends, it stretches. If you move near the speed of light, your clock ticks more slowly than one at rest. Time it seems, is not fixed, it is relative. Einstein's general relativity deepened the mystery. He showed that mass curves space and time. The stronger the gravitational field, the more slowly time flows. Near a black hole, seconds stretch into centuries, and at the event horizon, time appears to stop altogether. Kaku calls this the flexible fabric of space-time, a seamless unity of geometry and duration. In this view, the universe is not a stage with actors, but a living structure, where even the script of time is shaped by matter. The arrow of time. Yet while physics allows time to run in any direction, our experience says otherwise. We remember the past, but not the future. We age, we grow, we change. Ice melts, but never unmelts. This is the arrow of time, and it is deeply tied to a concept called entropy. Entropy is a measure of disorder, and according to the second law of thermodynamics, it always increases. Over time, systems evolve from order to chaos, from low entropy to high. Kaku sees this as the engine behind the arrow of time. From the highly ordered state of the Big Bang, the universe has been winding down, spreading out, growing more diffuse. But why did the universe begin in such a low entropy state? That question, he says, may hold the secret not only to time's direction, but to its ultimate end. Time travel, science or science fiction? No topic excites the imagination quite like time travel. From ancient myths to modern films, the idea of visiting the past or peering into the future has fascinated humankind. Kaku approaches this with careful curiosity. While time travel into the future is possible through relativity, simply by moving fast or near strong gravity, the past is more complex. Some solutions in Einstein's equations, like wormholes or closed time-like curves, suggest that backward time travel might be theoretically allowed, but they often require exotic matter, negative energy, or conditions we cannot yet produce. Still, Kaku entertains the possibility that advanced civilizations may one day master time, using it not just for exploration, but to reshape their fate. Is time an illusion? Some physicists go even further. They ask, what if time as we perceive it is not fundamental at all? What if it is a construct of consciousness, a way for our brains to make sense of change? Kaku explores ideas from quantum gravity suggesting that space and time might emerge from deeper laws, perhaps from networks of information, vibrating fields, or even consciousness itself. In this picture, the past, present, and future may all coexist, like pages in a book. Time doesn't flow, we do. Timelessness and the sleeping mind. As you lay still, feel the mystery of time dissolve. Here, in the space between waking and sleeping, time loses its grip. Minutes stretch or vanish. Memories blur. Awareness becomes soft. Perhaps this state, this deep rest, is a reminder that not all reality is ruled by ticking seconds. Perhaps some truths are timeless, like the structure of a melody or the stillness of space. Kaku's vision of time is not cold or mechanical. It is poetic. It invites wonder. It shows us that behind every ticking clock lies a deeper rhythm, one that moves galaxies and guides dreams. Section 9. Dimensions beyond the visible. When we gaze into the night sky, what we see appears vast enough. Billions of stars, countless galaxies, nebulae stretching like clouds across the black. But what if what we see is only a shadow of something far greater? Michio Kaku suggests that reality may not be confined to the 3 dimensions of space and the 1 dimension of time that we know. Instead, the true universe may include hidden dimensions, silent, invisible, yet fundamental. The legacy of string theory. At the heart of Kaku's work lies a bold and beautiful idea, string theory. In this theory, the tiniest particles, the electrons, quarks, and neutrinos, are not points, but tiny, vibrating strings. Like the strings of a violin, their vibration determines their properties, mass, charge, spin. But these strings can only exist in a universe with more than 4 dimensions. In fact, string theory requires 10 or 11 dimensions for the mathematics to work. These extra dimensions are not out in space like distant stars. They are curled up, compacted, perhaps smaller than an atom, folded within the very fabric of existence. We do not see them, not because they are not real, but because they are hidden, like pages in a closed book. Why so many dimensions? You might wonder, why does nature need so many dimensions? Kaku explains that each added dimension gives new room for the strings to vibrate and new possibilities for the laws of physics to emerge. In lower dimensions, the forces of nature behave chaotically, but in higher dimensions, unification becomes possible. Gravity, electromagnetism, and the nuclear forces can merge into a single elegant framework. These dimensions, then, are not decoration. They are the scaffolding upon which reality is built. The multidimensional universe. In this higher dimensional landscape, our familiar universe is like a membrane, or brain, floating in a higher dimensional space, sometimes called the bulk. We are confined to our brain, like insects on the surface of a soap bubble, able to move in certain directions, but not others. Meanwhile, gravity may leak into the bulk, which could explain why it seems so weak compared to other forces. Kaku imagines that there may be other brains, other universes, floating nearby, parallel worlds separated by a fraction of a millimeter, yet forever out of reach. These ideas are speculative, but deeply mathematical, and they offer one of the most compelling visions of how the cosmos could be layered, like an unseen symphony. Dimensions and the human mind. It is difficult for the human brain to imagine extra dimensions. We live in a world of length, width, and height. Our intuition is built on what we can see and touch. But sometimes, to glimpse the deeper nature of reality, we must leave behind our instincts and trust in the language of mathematics. Kaku says, physics is the only science where you can talk about things you cannot see. Still, even within the mind, we feel echoes of higher dimensions, in dreams, in music, in thought patterns that stretch beyond the linear. Maybe, in some way, the mind is drawn to these hidden layers because it came from them. A universe with depth beyond sight. As you sink deeper into rest, imagine that your bed is floating, not just in space, but in a higher dimensional sea. Imagine that every cell in your body is quietly vibrating, tuned to frequencies beyond time. Imagine that your consciousness too is not confined, but reaching, feeling the edges of something vast, something folded just beyond the senses. In Kaku's universe, we are not small. We are multidimensional beings living in a multidimensional world. And perhaps, as science and spirit evolve together, we will learn to see beyond the visible. Sleep now, in the arms of unseen dimensions. Let your mind drift through higher spaces. Let wonder be your pillow. Section 10. The Mind of God, a physicist's spiritual inquiry. As the stars swirl overhead and your breath slows into a gentle rhythm, you may wonder, is there meaning behind all of this? Is the universe random or intentional? Michio Kaku, though a theoretical physicist grounded in mathematics and science, often speaks of what he calls the mind of God. Not a religious God seated on a throne, but something more abstract, more elegant, more universal. The language of the cosmos, Kaku believes that the universe is not just matter and energy, it is information. Beneath the particles, beneath the stars, lies an intricate mathematical order, a code. It is this code that gives rise to the laws of physics, to space and time, to life and thought. And so, when he speaks of the mind of God, he refers to the totality of the laws of nature, the mathematical harmony that governs all things, from the heartbeat of atoms to the spiraling dance of galaxies. To Kaku, understanding this harmony is the ultimate goal of science. It is our modern version of what ancient philosophers once called enlightenment, a universe fine-tuned for life. One of the deepest mysteries in cosmology is the fine-tuning of the universe. The physical constants, the strength of gravity, the mass of the electron, the charge of the proton, are set to astonishing precision. If any one of them was slightly different, the universe as we know it would not exist. Stars wouldn't form, atoms wouldn't bond, life would be impossible. Is this coincidence, luck, or something more? Kaku explores the possibility that we live in a multiverse, an infinite sea of universes, each with its own laws. In this view, most universes are sterile, but in a few rare ones, like ours, the conditions are just right for complexity and consciousness. We are not the center of creation, but we are part of a vast and majestic design. Science and spirituality. A new synthesis, though Kaku is not religious in the traditional sense. He often speaks with reverence. He sees science and spirituality not as enemies, but as two lenses focused on the same mystery. Science explains the how. Spirituality asks the why. When a physicist discovers a beautiful equation, one that unifies forces, predicts phenomena, and mirrors reality, it evokes something akin to awe. Einstein once said, "The most incomprehensible thing about the universe is that it is comprehensible." Kaku agrees. The fact that our minds, built from stardust, can glimpse the underlying logic of the cosmos is, in itself, a kind of miracle. What is the mind of God? So what is the mind of God truly? To Kaku, it is cosmic music, the vibrations of tiny strings in 11-dimensional space. It is the song of existence, resonating in harmony, from the smallest particles to the largest structures in the universe. If we could see all the dimensions, hear all the frequencies, understand all the symmetries, then perhaps we would see what Kaku calls a grand design, not imposed by a deity, but written into the fabric of space-time itself. A mindless universe would be chaotic, but ours is not. It has order, laws, rhythm. And from that rhythm, we emerged. A restful return to wonder. As you rest now, let these thoughts drift like clouds above your mind. You are not separate from the cosmos. You are a part of it, made of its dust, animated by its laws, aware of its beauty. Sleep with the quiet knowledge that the universe is not cold or empty. It is alive with mystery, filled with patterns, and perhaps touched by something timeless that hums beneath it all. Let that hum carry you into peaceful sleep. Section 11. Cosmic Evolution. From simplicity to consciousness. Drift gently now. Let your thoughts settle like dust in a quiet room. For in this chapter, we follow a journey, one that spans billions of years. From simplicity to stars to thought. Michio Kaku often reflects on the astonishing fact that the universe, born from formless energy, has evolved into a place where conscious beings can observe and question it. This, to him, is not just a tale of physics, but a story of cosmic evolution. The beginning, simplicity and elegance. The universe began in stunning simplicity, a single point, a singularity. No atoms, no light, no time, only energy, pressure, curvature. In the first fractions of a second, the universe underwent inflation, expanding faster than the speed of light. Space itself was stretching, smoothing, and cooling. From this state of elegant simplicity, tiny fluctuations were born, quantum ripples almost too small to imagine. These ripples, over time, would grow into galaxies. Kaku marvels at how quantum mechanics, usually confined to the microscopic, helped shape the macroscopic structure of everything we see. The rise of complexity. As the universe cooled, matter formed, hydrogen, helium, simple elements floating through a vast dark sea. Gravity began to sculpt. Clouds of gas condensed into stars. In the hearts of those stars, fusion ignited. Light returned. Heavier elements, carbon, oxygen, iron, were forged in the fire. And when those stars died, they scattered their ashes across space. These ashes would one day become planets, oceans, life. To Kaku, this is one of the great miracles, that the same forces which shape galaxies can also shape cells, brains, and civilizations. The laws of physics are not just cold mechanics. They are creative, sculpting complexity from the raw clay of simplicity. From biology to thought, life on Earth began as molecules dancing in warm pools. Self-replicating chains of atoms, evolving over time, becoming more refined, more aware. Eventually, a brain formed, then language, then memory, then the first creature that looked up at the stars and wondered, where did we come from? What is all this? Kaku sees this not as a break from nature, but as nature awakening. Consciousness, in his view, is the universe becoming aware of itself. We are not observers standing apart. We are made of the same elements forged in ancient stars. We are physics, dreaming. The arrow of evolution. Throughout the cosmos, complexity tends to rise. Not always, not everywhere, but in pockets, in stars, in galaxies, in biospheres. Order emerges, thrives, and adapts. Kaku believes that this pattern is not accidental. It may be the natural consequence of information-seeking structure, of systems reaching for balance, intelligence, and self-organization. In this light, the emergence of mind is not a fluke. It is written into the fabric of possibility. Perhaps even other parts of the universe, distant and hidden, have produced minds of their own. The sleeping universe within. And now, as you drift further into rest, remember this. Your mind is the product of cosmic evolution. Each thought you have, each memory you recall, is a continuation of a journey that began in the silence of the Big Bang. You are the universe, dreaming in slow motion, a flicker of awareness in a sea of stars. Let that thought comfort you as you fall into sleep. For to rest is to return briefly to that great simplicity, and from that quiet, like the cosmos itself, new wonder will arise again. Section 12. Time's illusion and the shape of destiny. Close your eyes now. Let time slow. Let each breath be a gentle wave on the surface of a vast cosmic ocean. Because in this chapter, we visit something that flows through every corner of existence, and yet is one of its deepest mysteries, time. To most of us, time feels like a river. We are born, we live, we age, and we pass. But according to Michio Kaku and the laws of physics he studies, time may be far more mysterious and far less linear than we imagine. Is time an illusion? Einstein once said, "The distinction between past, present, and future is only a stubbornly persistent illusion." Michio Kaku expands on this. He suggests that time, like space, is a dimension, not something that ticks, but something that is. The past, present, and future may all exist simultaneously, like pages in a book. You, the observer, flip through those pages, but they are all already there. From this perspective, the flow of time is not a property of the universe, but of consciousness. We perceive change. We experience now. But in the equations of physics, those silent, eternal symbols on the chalkboard, time does not flow. It is simply part of the structure. Wormholes and time machines. Kaku also explores a provocative question. If time is a dimension, could it be traveled? According to Einstein's theory of general relativity, the fabric of space-time can bend, twist, and even form shortcuts called wormholes. These hypothetical tunnels could, in theory, connect 2 points in space or in time. Kaku, with cautious excitement, explains that while such travel remains far beyond our reach, the math does not forbid it. There may exist advanced civilizations millions of years ahead who have learned to fold space-time, to navigate it the way we navigate oceans. Could they visit the past? Could they glimpse the future? The answers remain hidden, but the very fact that physics allows the question tells us how strange and rich reality might be. The thermodynamic arrow. Still, there is something that gives time its direction, the arrow that moves from order to disorder. It's called the second law of thermodynamics. This law says that entropy, the measure of disorder, tends to increase over time. An ice cube melts, a star burns out, a memory fades, and so time's flow may be deeply tied to information, how it is created, lost, or rearranged. In the early universe, entropy was low. Everything was organized, compressed. Now, the universe is expanding, cooling, becoming more disordered. Kaku sees this not as decay, but as a transition, from simplicity to complexity, from order to the infinite potential of form, the fate of time and the universe. So what becomes of time at the end? There are many theories. In one, the universe expands forever, stretching space and time until everything grows cold and dark, a state called the heat death. Galaxies drift apart, stars flicker out, time itself slows in the empty vastness. In another theory, the universe could reverse, gravity pulling everything back into a big crunch, time running backward, returning to where it began. Or perhaps the universe buds off new universes, like branches from a cosmic tree. Time might be local to each branch, looping or restarting anew. Kaku doesn't pretend to know which fate awaits, but he emphasizes that time, as we know it, may not survive the journey. It may dissolve into a greater structure, a deeper pattern, living inside a mystery, and yet, here you are. Not at the end of time, not at its beginning, but somewhere in between, riding the current of now. Let that be enough for tonight. Let your thoughts drift through the folds of memory and imagination. Feel time stretch, slow, even stop. Because in sleep, we too step out of the clock. We leave behind the ticking, the counting, the striving. And we remember that beneath it all, beneath the hours, the calendars, the ages, there is simply being. The stars do not rush. The planets do not worry. They turn in silent rhythms. And you, a pattern in time, are allowed to rest. Section 13. The multiverse. Infinite realities beyond our own. Let your breath deepen now. Let each inhale carry you farther from the familiar, and each exhale soften the edges of what you thought reality meant. Because tonight, we drift beyond the boundaries of this universe into others. Michio Kaku often speaks of the multiverse, the idea that our universe may be just one of many. Not metaphor, not poetry, but science. A sea of universes. When cosmologists study the origins of our universe, they notice something strange. The laws of physics here, our version of gravity, electromagnetism, nuclear forces, are tuned just right for stars, galaxies, and life. But why? Why these laws and not others? String theory, one of the fields in which Kaku is deeply involved, provides a possible answer. It predicts not one universe, but an infinite number, each with its own version of reality, some with different physical constants, others with no atoms, no stars, no time. And we live in a rare branch where the conditions allowed complexity to flourish. The cosmic foam Kaku imagines the multiverse as a kind of cosmic foam, a churning ocean of space-time bubbles. Each bubble is a universe. Each bubble expands, evolves, and perhaps even dies. The Big Bang that created our universe may not have been the beginning of everything, just the moment our bubble separated from the foam. Other bubbles could be forming right now, all around us, outside the reach of our instruments and senses. Their skies may glow with different light. Their matter may behave in unfamiliar ways. They may hold beings, thoughts, and dreams we could never imagine. Parallel worlds and decision trees. But the idea goes even deeper. In quantum physics, the concept of the many worlds interpretation suggests that every quantum decision, every flicker of possibility, creates a branching of worlds. According to this theory, every time a particle chooses a path, the universe splits. One branch for each outcome. One world where the coin lands heads, another where it lands tails. You sitting here now might exist in countless versions, some nearly identical, others radically different. You might have chosen a different path, a different life, one that still unfolds somewhere. Kaku entertains these ideas not as science fiction, but as real consequences of the mathematics. In his view, the multiverse is not fantasy. It may be the most natural conclusion of our best theories. Implications for the human spirit. So what does it mean to live in a multiverse? Are we smaller than we thought? Or are we part of something unimaginably vast? Kaku believes this understanding should not diminish us, but elevate us. It means we are part of a grander structure, a cosmic symphony with infinite verses. And in this symphony, our universe is a melody, a rare and beautiful one. Even if there are other worlds, it does not make ours less real. If anything, it makes our awareness more precious, more miraculous. You are awake in one strand of possibility, drifting now through thought and wonder, safe in the arms of a universe that allowed you to be. Rest in the infinite. And so, as you settle deeper into stillness, know this: the universe you inhabit is not alone. There may be others singing in parallel, never touching, never seen. You are a note in a great branching chorus. You are an echo of probability, riding a ripple through cosmic time. And as your breath slows and your body softens, you return to that place of infinite possibility, the place before decisions, the place where all dreams begin. Let it hold you now. Let it carry you beyond stars. Let yourself drift, not just into sleep, but into the gentle, endless sea of what might be. Section 14, The Mind of God. Order in the chaos. The stars are quiet tonight, and so are you. Let your thoughts rest gently now, like snowflakes drifting down onto a silent field. Because in this section, we explore a question that transcends science and enters the realm of wonder. Does the universe have a mind, a purpose, a design? Michio Kaku often speaks of what he calls the mind of God. But unlike religious interpretations, he does not imagine a personal anthropomorphic deity. Instead, he sees the mind of God as the order and beauty found in the laws of physics, harmony in the equations. The universe, he says, is not random chaos. From the spiral arms of galaxies to the vibrations of subatomic particles, there is a structure, a rhythm beneath the surface. String theory, which Kaku champions, proposes that the universe is made of tiny vibrating strings of energy. These strings, when they vibrate at different frequencies, give rise to the particles and forces we observe. To Kaku, this is not just physics, it is music. He describes the laws of the universe as a symphony, and to him, the mind of God is cosmic music resonating through the 11-dimensional hyperspace of string theory. The unification of forces. One of Kaku's lifelong dreams is to discover the theory of everything, a single equation that unites all the forces of nature: gravity, electromagnetism, the strong and weak nuclear forces. Einstein spent the last years of his life searching for such a theory. He believed that nature must be unified, that the same elegant principle which guides the falling apple also governs the dance of galaxies. Kaku believes that we are closer than ever, and when we find that equation, when we write it down, it may be no longer than a few inches. Simple, pure, elegant, and in that moment, we may feel we are glimpsing the source of all structure, the blueprint behind time and space. That, Kaku says, is the mind of God, meaning in a mathematical universe. But what does that mean for us? Are we just equations, just patterns in a grand machine? Kaku offers a gentler thought. If the universe is mathematical and we are conscious, then consciousness is also part of the equation. We are not separate from this harmony. We are notes in the song, not by accident, but by unfolding. You are not a mistake. You are not noise. You are a ripple in the great music. And even as you sleep, the melody continues. Section 15, the future of humanity in a cosmic context. Now, let us turn our gaze forward, toward what lies ahead, not just for stars and galaxies, but for us, for humanity. Michio Kaku often wonders, what is our place in the cosmos? Are we destined to vanish with our planet, or to rise as a galactic species? In his view, the universe offers two paths: extinction or expansion. Type 1, Type 2, and the third is civilizations. To explain this, Kaku uses the Kardashev scale, a way to measure the advancement of civilizations by their energy use. A Type 1 civilization harnesses the power of its planet: wind, sun, oceans, and earthquakes. A Type 2 civilization controls the energy of its star, perhaps by building a Dyson sphere. A Type 3 civilization commands the energy of an entire galaxy. Where are we? We are a Type 0 civilization, still burning dead plants for energy. But Kaku believes we are rapidly approaching Type 1. The internet, global communications, renewable energy, these are the beginnings of planetary civilization. But we are fragile. The great filters. Many scientists worry that civilizations might not survive the transition to Type 1. Nuclear war, climate collapse, pandemics, artificial intelligence. These are the filters. Kaku calls our current era the most dangerous in human history because we have the power to destroy ourselves, but not yet the wisdom to avoid it. And yet, he remains hopeful. He believes intelligence is not just biological, it is structural. It can be nurtured. Our destiny, he says, is to survive these tests, to grow into a species that explores space, colonizes planets, and spreads life and mind across the stars. The awakening of the cosmos. In Kaku's most poetic moments, he imagines a future where the universe itself is filled with awareness. where life is not confined to Earth, but has seeded the void, where minds, natural or artificial, drift between stars, building, dreaming, evolving, where the universe no longer just is, but knows. And in that distant age, long after we are gone, our dreams may still echo, our choices may still shape the path. Even now, your thoughts, your voice, your presence, they are part of the long awakening of the cosmos. Sleep with hope. So rest tonight, not in fear of endings, but in hope for beginnings. The universe has no ceiling for wonder, no boundary for imagination. And you, small though you may feel, carry in you the seed of stars and the spark of possibility. Close your eyes. Let the quiet of space wrap around you. And remember, the future is still unfolding, and the music has only just begun. Section 16, Consciousness. The universe becoming aware of itself. In the quiet space between thoughts, there is a presence, a light that does not shine outward, but inward. We call it consciousness. And tonight, as you drift closer to sleep, we explore what Michio Kaku believes may be the greatest mystery of all. Not black holes or dark energy, but the simple question, why are you aware? The mirror of the mind. For centuries, science studied the world as if the observer did not matter. But the advent of quantum mechanics changed that. It showed that the act of observation alters reality. A particle behaves differently when it is watched. It collapses from a cloud of probabilities into a definite state because of you. This strange effect led many to ask, does the universe need observers? Is consciousness woven into the fabric of reality? Michio Kaku, blending physics and neuroscience, suggests something profound. The universe has evolved to a point where it can contemplate itself. Through you, through your thoughts, through the inner theatre of your dreams. A ladder of awareness. Kaku proposes that consciousness is not binary. It is not on or off. Instead, it is a scale, a gradual unfolding. He classifies levels of consciousness. Level 1, basic awareness of space, like reptiles sensing their environment. Level 2, social awareness and emotion, like mammals recognizing others. Level 3, self-awareness, reflection, imagination, unique to humans. And perhaps a level 4 is coming, a higher consciousness, expanded by technology and connected by artificial intelligence. A mind that no longer fits inside a single brain, but spreads across networks, satellites, and space. In Kaku's eyes, this is not science fiction. It is the next step in evolution. The soul in the circuit. This raises deep questions. If a machine can become conscious, is it alive? Does it dream? Does it suffer? Does it know beauty? Kaku sees a convergence coming between biological minds and digital ones. He believes we may one day upload consciousness itself, scan the brain, decode its patterns, transfer them to silicon, a backup of the soul, a second life among the stars. You might sleep tonight in this body, but the future may awaken you somewhere else, with the same memories, the same thoughts, but in a new form. And perhaps someday minds will travel at light speed, not in ships, but as streams of consciousness, broadcast into the cosmos, the dreamer and the dream. So what is consciousness? Kaku doesn't claim to know all the answers, but he believes it is the rarest phenomenon in the universe, and perhaps its most important. Without it, galaxies would turn, stars would burn, but there would be no one to witness them. No wonder, no meaning. You are not apart from the universe. You are the universe, thinking about itself. You are the dreamer, and also the dream. So as your eyelids grow heavy, as your thoughts dissolve into sleep, know this. In you, the cosmos has found a voice. In your silence, the stars find peace. Section 17. Colonizing the cosmos. Humanity among the stars. You are floating now. Not just in sleep, but in a vision of the future. A future where Earth is not our only home. Michio Kaku believes that if humanity is to survive the challenges of the 21st century, we must become a multi-planetary species. This is not a fantasy. It is a necessity. The fragile blue dot. Look back at Earth for a moment, from the silence of space. It is delicate. A thin skin of atmosphere protects us from the void. One asteroid, one supervolcano, one great war, and everything we know could vanish. Kaku calls this moment in human history a bottleneck, a test. We have the power to destroy ourselves, but also the ability to escape our cradle and build something greater. He sees space colonization as an insurance policy, not abandoning Earth, but ensuring that humanity lives on, no matter what happens. First stop. Mars. Kaku believes the first real step will be Mars. The red planet is close, reachable, and already being targeted by space agencies and private companies. He envisions cities under domes, powered by solar energy, supported by artificial intelligence. It won't be easy. Mars is cold, dry, and its atmosphere is thin. But we have the tools, and more importantly, the vision. In time, we might terraform its surface, unleash greenhouse gases to warm the planet, melt ice caps, and create oceans under alien skies. A second Earth. A new world for future generations to dream under unfamiliar stars. Beyond Mars, the moons of Jupiter and Saturn. Once we master Mars, the outer solar system calls. Kaku is fascinated by moons like Europa and Titan. Europa may have vast ocean beneath its icy crust, an ocean kept warm by tidal forces. And where there is water, there may be life. Titan, Saturn's moon, has lakes of methane and a thick atmosphere. It is one of the most Earth-like bodies in the solar system, though strange and cold. These worlds may become way stations, laboratories, places to test our courage and expand our definition of what life can be. Interstellar hopes. But Kaku does not stop at our solar system. He dreams of reaching the stars. It sounds impossible. But he discusses theoretical propulsion systems. Laser sails, fusion engines, even warp drives. If we can bend space itself, we might one day fold the distance between stars and arrive not in centuries, but in days. Planets orbit other suns. Some may be habitable, some may already hold life. To reach them is to step into the true future of our species, not just as Earthlings, but as citizens of the galaxy, the seeds of consciousness. Kaku sees life as the universe becoming aware of itself. And to spread life is to spread awareness, to bring thought to places that have only known silence. Every colony, every outpost, every tiny settlement among the stars is a candle lit in the vast darkness, a whisper that says, "We were here, we dreamed, we reached for the sky and kept going." And as you breathe slower now, as the image of distant planets fades into the soft darkness behind your eyelids, know this: the future is vast, but it is not empty. It is waiting for us. Section 18. The Destiny of Intelligence. A Cosmic Perspective. You've come far now, beyond galaxies, beyond time, and yet here you are, still listening, still wondering. As the stars drift silently overhead, we ask, what is the destiny of intelligence in the cosmos? For Michio Kaku, this is more than a scientific question. It is a philosophical one, a spiritual one. From dust to thought, we began as stardust, atoms forged in dying suns scattered across the galaxy, eventually coalescing into life, mind, and civilization. We are nature made aware. We are the universe contemplating its own existence. Kaku believes this is not coincidence. It is part of a cosmic unfolding. Given enough time and stability, intelligence must emerge. Just as gravity shapes stars, consciousness emerges to observe them. This is not mystical, it is structural. Intelligence, he argues, is a natural product of complexity, and as complexity increases, so too does the awareness within it. The evolution of mind's Kaku envisions a future not of static intelligence, but of evolving forms. Our brains, once shaped by survival, are now merging with technology. AI, brain-computer interfaces, genetic editing, all signs that consciousness is expanding its reach. We are not at the end of evolution, we are at its beginning. In the distant future, Kaku imagines intelligence that is no longer tied to biology, minds as patterns of energy, beings made of light, able to move through space, manipulate matter, and even shape time. Such beings may already exist, and one day we may join them, not as conquerors, but as fellow explorers of the infinite. A conscious universe. But here, Kaku offers a deeper possibility, that the universe wants to know itself, that from the start, its laws were tuned not just for matter and force, but for conscious experience. The emergence of mind may not be an afterthought, it may be the goal. And if intelligence is the ultimate expression of the cosmos, then we, tiny, temporary beings, are not irrelevant. We are necessary. Each act of thought, each spark of imagination, each dream beneath the stars, is part of the universe awakening. Your place in the story, as you lie still now, listening with your heart more than your ears, know that this story includes you. You are part of a long continuum, from atoms to life to intelligence to something more. Kaku does not claim to know where it all leads, but he is certain of one thing. The journey has only just begun. The universe is not done evolving, and neither are you. So let your breath soften, let your body rest. You are stardust that learned to listen. You are thought floating in the dark, and you are not alone. Section 19. The Multiverse and Hidden Dimensions, peeking beyond the cosmic veil. Close your eyes now, and imagine that everything you know, the stars, the galaxies, the black holes, and the cosmic web, is just one drop in a much larger ocean. Michio Kaku believes that what we see around us may not be all there is. Beyond the boundaries of our universe, there may be countless others, each with its own laws, its own physics, its own dreams. This is the idea of the multiverse, and it's not science fiction anymore. A symphony of universes. In string theory, the framework Kaku champions, our universe is not a lone violin, but part of a cosmic symphony. Each universe is like a vibrating string, with its own frequency and structure. Some may be similar to ours, others may be unrecognizably strange, filled with light that moves backwards, or time that flows in spirals. We exist on a three-dimensional membrane or brain, floating in a higher dimensional space. Other brains may float beside ours, invisible but near, and sometimes they may collide. Kaku suggests that such a collision may have sparked our own Big Bang, an echo of deeper dimensions rippling into ours. The hidden dimensions. According to string theory, the universe may have not just 3 dimensions of space, but 10, or even 11. Most of these dimensions are curled up, folded tightly into spaces too small to see, but they shape the very forces that bind the universe together. Why is gravity weaker than the other forces? Kaku believes it may be leaking into higher dimensions, like sound escaping through a crack in the door. And just as a flat shadow is only a projection of a 3D object, our universe may be a projection of something far more complex. A deeper reality, one we can barely imagine, one that science is only beginning to touch. Contact with the beyond Kaku often wonders, could we ever detect another universe? Perhaps in the background radiation of the cosmos, we may one day find signs of a bruise where our universe once bumped into another. Perhaps quantum fluctuations are tiny glimpses into other realms, and maybe, just maybe, in the distant future, our descendants will find a way to reach them. Not with rockets, but through manipulation of space and dimension itself. They might build gateways, fold space-time, step through the veil, and greet the unknown as kin. A cosmic humility. These ideas are vast, and yet Kaku reminds us we must approach them with humility. We are still at the beginning of our journey, still fumbling in the dark. But every question, every experiment, every spark of curiosity brings us closer to the edge of understanding. Perhaps we'll never know what lies beyond. Or perhaps, in dreaming, we already touch it. As your breath slows now, as your mind drifts between thought and stillness, remember, you are part of a universe that may be one of many, and in each one, there may be someone like you, wondering, dreaming, gazing at stars no one else will ever see. Section 20. Epilogue. Dreaming with the universe. You've traveled far, across stars, through time, into dimensions unseen. You've heard the voice of science and the quiet wonder that lies just beneath it. Now it's time to rest, to let go, and to drift with the current of the cosmos itself. We are the universe, dreaming. According to Michio Kaku, we are not separate from the universe. We are not outside observers. We are it, thinking, dreaming, wondering what it is. The atoms in your body were forged in ancient stars. The thoughts in your mind are shaped by billions of years of evolution. And your imagination is a reflection of what the universe could become. Every discovery, every equation, every vision of the future is a way the cosmos expresses itself. And so, when you dream tonight, you are participating in the universe's deepest purpose, to know itself. The road ahead, Kaku reminds us that the universe is not finished. It's still unfolding. New stars are being born. New worlds are waiting to be explored. New minds will awaken, and they will continue the journey we began. Humanity is still young. Our knowledge, a mere flicker. But the path is clear. From stardust to life to thought to something more. We may one day control gravity, harness the energy of galaxies, spread life to the corners of existence, and even in the distant future, as stars fade and time stretches into silence, our legacy, our light, may remain. A moment of stillness now. Inhale slowly, exhale deeply. Feel the pull of gravity anchoring you to your bed, just as the earth is held by the sun and the galaxies by invisible threads of dark matter. You are safe. You are timeless. You are part of something beautiful. Let the final thoughts of this journey be soft ones. You are the product of billions of years of cosmic evolution. You are here, and the universe is listening. Closing whisper. As Michio Kaku might say, the universe is a symphony of strings, and we are playing its music. Let that symphony cradle you now. Sleep well, dream gently, and remember, the stars are not just above you, they are within you.